So in this video, we're going to talk about how to write lines of best fit using linear regressions. So when you plot data points on a grid, the resulting graph is called a scatter plot. This scatter plot shown here tells you the relationship between a dog's height and its weight in pounds. By looking at the pattern of the data points in a scatter plot, you can draw in a trend line that will represent the pattern in the data. The trend lines are considered to be a good fit or a bad fit depending on how well they represent the data in a graph. So patterns in the data points can tell you the type of association or relationship between the two variables. If the data points increase from left to right in the scatter plot, you have a positive association. If the data points decrease from left to right in the scatter plot, you have a negative association. If the data points show a random pattern, you have no association. We can also describe the strength of the association. If the data points don't closely fit a line and they're more spread out, we have what's called a weak association. If the data points pretty closely fit a line, we have a strong association. If the data points exactly form a line, we have a perfect association. So let's look at this example and describe the association between the variables. So if we look at this, we can see here that the values increase as we go left to right. So if the values increase, we know that we have what's called a positive association. So now we need to determine the strength of the association. So notice that these points pretty closely approximate a line. So I would say that this is overall a strong positive association. So we can measure this using something called the correlation coefficient, which is represented by R. So correlation coefficients can have a value anywhere from -1 to 1. So a value of -1 will be a perfect negative correlation. A value of +1 will be a perfect positive correlation. Coefficients that are closer to 0 will indicate a weak correlation. So let's describe the associations for these different correlation coefficients. So we have -0.25, so that is a negative correlation, and since the value is closer to 0, we would say that that is a weak negative correlation. If we have R equals 0.98, 0.98 is closer to 1, so we would say that this is a strong positive correlation. If we have -0.55, well, that's sort of in the middle, right? So we would say that it is a moderate negative correlation. So you can determine the strength of an association based on the value of the correlation coefficient. So let's estimate the correlation coefficient given a scatter plot. So you can see that this scatter plot shows you values that pretty closely approximate a line, and then the values do go up as we go left to right. So we know that it's a positive correlation, so since the values are pretty close to a line, we would say that it is a strong positive. If we want to estimate a number, we can say something like maybe 0.9, right? It's pretty close to 1. It's not a perfect correlation, but it's pretty close. So what we can do is we can actually write equations for these lines of best fit, which are also called regression lines. So lines of best fit are a line that will best model a given set of data points. The reason we want to write these is because we want to look at trends in the data and we want to be able to predict values. So we're going to use our calculator to help us write a line of best fit. So there are two ways you can do this. You can use your TI calculator, or you can do this in Desmos. I'm going to show you both ways, but I'm going to start off in this video showing you on the TI calculator. So if you would prefer to use Desmos, please fast forward to the part where I talk about Desmos. Okay, so here's the TI calculator instructions. So let's write a line of best fit for the data given in this table here. So what you're going to do is you're going to create a table. If your data is in a graph, you're going to want to create an XY chart like what's given here. So what we're going to do is we're going to turn our calculator on. We're going to click Stat and then Enter or choose 1 for Edit. So this will give us an L1, L2, which is kind of like our XY chart. Notice I already have values in L1 and L2, so what I'm going to do is arrow up until the title of the column is highlighted, click Clear, and then Enter to clear out that column. I arrow over to L2, go up, click Clear, and then Enter to clear out that column. Now I can enter these values from the table into L1 and L2. L1 is going to get all of the X values, so I'm going to type them in, hitting Enter after each one. So 2, 4, 7, and 11. Now I arrow over to L2. I'm going to enter the Y values into L2. So I have 7, 10.5, 15.75, and 22.75. So now what we're going to do is we're going to ask the calculator to figure out a line of best fit for the data. So what we're going to do is we're going to click Stat, arrow to the right so that calculate is highlighted. We're going to choose option 4, which is linear regression. So you can arrow down to 4 or you can click 4 and then enter. So now you'll see this option right here. So we're going to just keep clicking enter until we go to calculate, and then you hit enter again. So now what it does is it gives us the equation of the line. It says y equals ax plus b, then it says a is 1.75 and b is 3.5. So what we're going to do is we're going to plug these values into ax plus b to write our equation. So our equation will be y equals 1.75x plus 3.5. So that is how we write the equation of a line using linear regressions on the calculator. So what you can do, the benefit of this is that you can predict future values. So values that are not on the table, we can predict using this equation now. So suppose we want to find the value of this function when x equals 15. Well, what we can do now is we can use this equation that we have, right? We can plug in x equals 15, so we get y equals 1.75 times 15 plus 3.5. Now we can use our calculator to simplify this. So we get y equals, so let me go back to the the home page. So we have 1.75 times 15, and then I'm going to add 3.5 to that. And so that gives me a y value of 29.75. So I can use this equation that we just wrote to predict a value that is not given in the table. So let's try another example. This gives us the total grams of fat and the total number of calories in different fast food sandwiches. So let's see if there's a relationship between the fat grams and the total calories in fast food. So we're going to start off once again entering this data into our table. So I'm going to call this left column, I'm going to call that L1, and then I'm going to call the total calories, I'm going to call that L2. So remember, we're going to start off by going to Stat, hit enter on edit. We're going to clear, so I'm going to go up until the title is highlighted, click clear, enter, go over to L2, go up, click clear, and then enter. So now in L1, I'm going to enter the fat grams. So I have 9, 13, 21, 30, 31, 31, 34, 25, 28, 20, and 5. So when you're entering a lot of values, just make sure, scroll back up and make sure that you've kind of entered everything correctly, just to be sure. Now in total calories, I'm going to enter the values that I have. So 260. Okay, 34 is 590. 25 is 500. 560. 440, and 300. So now I have all of these values. If I want, I can view the scatter plot. So if I want to see the graph, what I need to do is I need to turn stat plot on. Okay, so I'm going to click second and then y equals to turn stat plot on. So I have to go to plot 1, hit enter, and then choose enter again to turn stat plot on. So then I'm going to click zoom and then arrow down or choose option 9, which says zoom stat. So if I hit enter, it will show me the scatter plot that is this set of data. So I can just say, predicting on the shape of it, I think it has a pretty strong positive association. But let's double check. Let's calculate the line of best fit, and let's calculate the R values to see if this is true. So I'm going to go back to stat, arrow to calculate, and then choose option 4, which is linear regressions. And then keep choosing enter until I go to calculate. And so now I have 11.7. So I'm going to write my equation now, which is 11.7 plus, let's see, 193.8. Okay, so that is the equation of the trend line. Well, what I can do now is I can actually figure out the R value. So to figure out the R value, I'm going to have to turn on that setting in my calculator. So what I'm going to do is I'm going to press second and then choose 0 because that's catalog. And then I'm going to have to scroll down to diagnostic on. So that is something that's going to tell me the R values. So I have to turn diagnostic on, which is down in D. These are in alphabetical order. So I choose diagnostic on and hit enter and then enter again. So that will now tell me my R values. So if I go back to stat, calculate, choose option 4, and then enter, it now tells me my R value. So you can see my R value is 0.97. So as we predicted, from our stat plot, this is a very strong positive association.